So your goal is to find dy by dx or the derivative, but this one is the implicit differentiation. This one is implicit function. So then to find the derivative, we're gonna use the implicit differentiation. Okay, and the expression we have x squared, I'm gonna copy it again, 4 times the square root of x times y, I write it as the power, x times y to the power 1/2 equals 6 times y squared. Because when we have the rule, we use the general power rule, or um, uh, what do you call the chain rule that has the composite function of the power and the other expression. No radical or no square root form as part of the formula that we use. Okay, to find the dy by dx, step 1 of the implicit differentiation, you're gonna find d by dx to all terms. Okay, so this is my step 1. So for each term, d by dx of x squared plus d by dx of 4 times x times y to the power 1/2 equals d by dx of 6 times y squared. And then for each term, you have to consider, like, do you need the basic rule? Do you need the general power rule? How do you know which rule you're going to apply? For example, the first one, you see x here,
Yeah.
x and x. So this part going to be the basic rule. Okay, the basic rule. So how to get this? So just the basic rule, the power rule, right? The derivative is 2x. Are we all good for this?
Mhm.
Yes. And then the second one, you have the number. This is called the constant multiple. Okay. So you don't have to do anything with the 4. It's treated as a coefficient. But this part, as you see, this is the x. You see x, but this is the one that doesn't look like x. So this part, you're going to use the general power rule. See the general? So that means you cannot use the basic, because the basic for just the function in x. Okay. And then similar to the last group here, you have the variable x, you have the variable y. They are not the same, but y technically is the function in x. So the last group, you still have to use the general power rule. All right. So work on the second term, the constant multiple. You don't have to do anything. Just copy the 4 down. And to use the general power rule, see the power is 1/2, right? So gonna
Mhm.
be gonna be 1/2 multiplied by whatever the quantity in there, which is the quantity x
XY.
times y, to the power 1/2 minus 1, and then multiply by the derivative of the inner function.
Mhm.
Okay, so I put here x times y. So this is the process of the general power rule, and where you can see this as the gx, and this is the gx. Recall the general power rule. So I write it here. General power rule. When you have the quantity g to the power n, when you find the derivative, it's going to be n, the quantity g, whatever in there, take the whole package, n minus 1, and then multiply by the derivative of the g. So the input here, you find the derivative, multiply on top of the normal power rule. Are we good with the middle term here?
Mhm.
Okay. And then the right term, same thing, the 6 as the constant multiple. So 6, and then multiply by treat y squared as when you find the derivative of y squared using the general power rule. The power is 2, and
Wow.
then the quantity y to the power 2 minus 1 multiplied by y prime, which is the dy by dx. So this portion is from the use of the general power rule. Okay? Stick with the rule and then apply to the terms within the expression, within the equation. Next step, we're gonna clean up. Okay, clean up, do step by step. That's why I recommend you to have like a lot of paper and write it out, and make sure you see your work very clear, so you can track your work and see what part that you still miss and which part is good. 2 and 4, reduced to be 2. And then the quantity x times y, the power now becomes negative 1 half. And the derivative of x times y, this is a multiplication.
Uh,
This part, you're going to use the product rule. You see the rule inside of the rule. What the product rule say? The product rule said you're going to have to use the first term multiplied by the derivative of the second term and then do the other way around. Okay, so this part we use the product rule. If you refer to what we did before, the product rule, like you have f times g, it's going to be the first term times the second derivative plus the first derivative times the second, right? The mix and match one. So with this way, we we kind of make it more clear, well, expand them all out for the the second term, the derivative of the second term. And then at the same time, work on the right term. 6 and 2, that's 12. Y to the power 2 minus 1, that's the power 1. And multiply by dy by dx. Okay, the right term is set. Leave it the way it is. And now look at the left term. What else that we have to do? We still have to clean up. The dy by dx, we leave it the way it is because our goal is to solve for dy by dx. But what is the dx by dx? It's 1. So I'm going to add more to the next step, which is 2x plus 2 times the quantity x times y to the power negative 1 half. And then x multiplied by dy by dx plus 1 times y, or just y, equals 12 times y times dy by dx.
can I tell you something?
Yes,
So I can fill on this way on the middle. So you have to distribute on, right? Distribute the 2xy negative
to
1
the
over.
power. Yes,
Yeah.
I'm going to have to distribute. So the next step, you have to ungroup everything to see individual terms. So right now we have the product of the 2 and the quantity to the power negative 1 half and the quantity in the bracket. You cannot leave it in the bracket. You have to expand until you see individual terms. And then you collect the term for dy by dx, which is the next step of the implicit differentiation. Okay, so at this step, you have the power negative. Here's the thing, you can carry as a negative power or rewrite the negative power as a positive power, but in the reciprocal form. Okay, so as we do this as 2x plus,
Yeah.
ah,
Okay.
yeah, someone said something.
Oh, so this box is what I can feel like how to how to use description on.
You can distribute it right now, or this is a way to make the problem cleaner. So let me add more room into the note here. Oops. Okay. So for this one, I recommend you to write this one into the reciprocal of the positive power. Okay. Here's a way to make the problem less complicated, but requires more skills in algebra. Now, when I get to this point, I'm going to clean up the denominator, x times y to the power 1/2, by multiplying the whole thing by x times y to the power 1/2. Okay. If I multiply the first one, I will get 2 times x multiplied by x times y to the power 1/2 plus 2 times x dy by dx plus y equals, and this can be 12 times y times x times y to the power 1/2. This is dy by dx, I miss that. So now I don't have the term involving the denominator. Okay. And next skill that we're going to use, if you did the homework section 11 to 17, this is a skill that you're going to use. So 2 times x to the first times x to the power 1/2 times y to the power 1/2. because the quantity a times b to the power n is a to the power n times b to the power n. All right, that's one of the skills that you're going to bring over. And next, I'm going to distribute 2 to the terms here. So I have plus 2 times x dy by dx plus 2 times y equals, and similar terms here that I have to use the same skill. So going to be 12 times y times x to the power 1 half times y to the power 1 half dy by dx. I do not have grouping symbol at this point, but I still have to clean up the power, like for this 2 and for the y and the y here, because at this point the skill that we're gonna use gonna be the skill that you have a to the power n times b times a to the power m. You're gonna add the power together. So this is another skill that you're gonna bring in. So in this case, you have the same base. You have the powers, so you're gonna add the power together. So it becomes 2 times x to the power 1 plus 1 half, which is 3 over 2. So this one from 1 plus 1 half. And then multiply by y to the power 1 half and plus 2 times y, 2 times x dy by dx plus 2y equals, for this part, you're going to add 12. I'm going to write x first and then y to the power. This is power 1 and power 1 half comes back to the power 3 halves. Okay, using these skills, this skill, and then multiply by dy by dx. Okay, so at this point, you have 1, 2, 3, 4, 4 terms, and then you're going to solve for dy by dx, which is the second step of the implicit differentiation. At this step, we're going to solve for dy by dx. To solve for dy by dx, we can collect the terms dy by dx together in one side. So 2x dy by dx, and bring this term over. So subtract both sides by 12, x to the power 1 half, y to the power 3 halves, dy by dx. And then the term that doesn't have dy by dx, we bring it over to the other one, the other side. Okay. And then since our goal is to find dy by dx, we're gonna factor the dy by dx and then collect the coefficient together with 2x minus 12, x to the power 1 half, y to the power 3 over 2 equals negative 2, x to the power 3 over 2, y to the power 1 half minus 2y. Because the goal is to solve for dy by dx. So leave dy by dx by itself and divide both sides by the coefficient of the dy by dx. So then the right hand side is negative 2, x to the power 3 over 2, y to the power 1 half minus 2y, all divided by the quantity 2x minus 12, x to the power 1 half, y to the power 3 over 2. So this is the unsimplified solution. Okay, but the main part is done, the whole process is done, except this is not the clean solution. Why is not the clean solution? Because you see the number 2 2 2 12, you factor the number 2 out, and then at the same time, well, do one thing at a time, like negative side, because the numerator has negative inside, so negative 2 factor it out, so we have x to the power 3 halves, y to the power 1 half minus y, all divided by, factor the 2 out, going to be x minus 6, x to the power 1 half, y to the power 3 over 2, and then 2 and 2 reduce. Now your dy by dx in the cleaner version is x to the power negative side, x to the power 3 halves, y to the power 1 half minus y, all divided by x minus 6, x to the power 1 half times y to the power 3 halves. Okay, the Hawk's learning will take the equivalent solution. If If you leave the answer in this form, it still take it. If you answer in this form, you get the same credit. Or if you can simplify more, if you can see what you can do more, you have the common factor y and the y here. Okay, and this is x, the x, but they don't have the same power. The technique of factoring is to take the lowest power out. Since this is a 1 is 1/2 plus 1/2, and similar to the power x, power 1 of the x on the bottom here. So this one can be simplified more as negative. I'm going to write one more step before we um, wrap up this problem. It's x to the power 1/2 times x to the power 1/2 minus 6x to the power 1/2 y to the power 3/2. So you see the common factor, common factor, common factor, common factor. You can take it out. So negative y to the 1/2 for the common factor of the top one. This is plus sign. This is plus sign, sorry, I messed up. So this is x to the power 3 over 2 minus y to the power 1 over 2, all divided by common factor of the denominator, which is x to the power 1/2. So x to the power 1/2 minus 6 times y to the power 3/2. And then you can answer in this form or another form. I know it's too many forms. The power 1/2 means it's radical. So the radical y, this is x, radical x minus radical y. Too much, right? You don't have to worry about simplify if you are done at this step. It just gets messier if you are not comfortable with the algebraic property. Okay, so they are different forms of the solution, but they all are equivalent. All right, so our goal is to find dy by dx, and we got dy by dx, and we are done for this problem.
Can I ask you a question?
Yes.
Can you go up a little bit?
Go up a little bit.
A little bit more. Yeah, a little bit more. Yeah, I think this part. I think this part. So is that like you separate the x 1/2 and y 1/2 on the power?
I use the property